International Weather Bulletin. Good day, ladies and gentlemen, and welcome to today's edition of the Weather Forecast News. We are now entering the early days of September, a particularly important period of the year for the Atlantic Basin. According to decades of climate records, September 10th is considered the climatological peak of the hurricane season in this region, when ocean surface temperatures, atmospheric humidity, and meteorological currents all converge to create the most favorable conditions for tropical cyclones to form and intensify. At this time of year, we usually see a parade of storms moving westward from the coast of Africa across the Atlantic, passing through the Caribbean Sea, and from there potentially heading into the Gulf of Mexico or striking the U.S. East Coast. Yet in 2025, the picture has been surprisingly quiet compared to other hurricane seasons. That calm, of course, is only relative, because one particular system is drawing the attention of both meteorologists and the public: a tropical disturbance temporarily designated as Invest 91L. This is now the focal point, a true wildcard in the coming days. It could easily fade away without leaving a trace, or it could evolve into Gabrielle, the next named tropical storm of the 2025 season. Satellite observations over the past several days show that Invest 91L lacks the organized structure we typically associate with storms. Instead, it appears as a messy cluster of scattered thunderstorms, sometimes showing a swirl, sometimes dissipating into nothing, with no clear and persistent center of circulation. The U.S. National Hurricane Center, NHC, currently estimates the chance of this system becoming a tropical depression within the next 48 hours at about 60%, and over the next 7 days, the probability rises to 90%. That is a high level of confidence, yet it doesn't guarantee storm formation. As the NHC itself notes, several unfavorable factors are still working against 91L. One of the first problems is its slow movement. Invest 91L is essentially crawling across the open ocean. Meteorologically, systems that move at 15 to 20 miles per hour often benefit from inflow and upper-level support, which enhance circulation. But when a system drifts too slowly, as 91L does, it churns up the ocean beneath it, pulling cooler subsurface water to the surface. This reduces sea surface temperatures, the very fuel a storm needs to grow stronger. Experts call this the phenomenon of upwelling, which effectively cuts off the system's own energy supply. Another challenge is the presence of Saharan dust. During summer and early autumn, powerful winds from Africa blow vast amounts of desert dust out over the Atlantic. This creates a massive, dry air shield that suppresses convection. On satellite imagery, we can often see arc clouds, curved cloud lines spreading outward, evidence of thunderstorms trying to form but being snuffed out by the dry air. Much like a flame extinguished by a strong gust of wind, the result is a constant tug-of-war. On one side, the system makes efforts to organize; on the other, the environment keeps tearing it apart. Many forecasters admit this is an unusual situation. Rarely do we see a system with such a high development probability on paper yet looking so weak and disorganized in reality. To complicate matters, the forecast models disagree. The USGFS model leans toward a scenario in which 91L eventually escapes the dry air, strengthens, and heads toward the Caribbean islands. Meanwhile, the European ECMWF model suggests the system will fail under pressure and dissipate in the Atlantic. This split forces forecasters to remain cautious. What's especially notable in 2025 is the widespread use of artificial intelligence, AI, in storm forecasting for the first time. Both Google's AI model and ECMWF's AI-based version favor the dissipation outcome. They simulate hundreds of scenarios, most of which end with 91L fading out before reaching the Caribbean. Still, there is skepticism, because 91L is a relatively small system, and AI models often perform better with large-scale structures. Could the algorithms be overlooking subtle but crucial details? Even the experts acknowledge they are learning as they go in this AI-driven hurricane season. So, what could happen in the coming week? If 91L manages to break free of the Saharan dust, it will move toward the leeward and windward islands. where conditions are more humid. Wind shear is lower, and sea surface temperatures exceed 28 degrees Celsius, ideal for storm growth. In that case, a tropical depression or even tropical storm Gabrielle could form. If not, the disturbance may simply wither away into scattered clouds. That is why the NHC issues such broad probability zones rather than pinpoint forecasts. It reflects the high uncertainty we face. For residents in the Caribbean and the U.S. southeast coast, there is no immediate danger over the next week. But in tropical meteorology, small shifts can lead to major outcomes. That's why islands like Puerto Rico, the Virgin Islands, and Dominica have already been advised to keep a close watch on daily updates. Meanwhile, in the Pacific, the picture is clearer. Hurricane Kiko has sustained impressive strength, with winds above 115 miles per hour. Satellite images show its eye intermittently disappearing and reappearing, a sign of resilience. Forecasts suggest Kiko may briefly re-strengthen before moving over cooler waters to the north. Where it will weaken, most likely, it will veer northward and pass above Hawaii rather than making landfall. This means the islands may avoid destructive winds but should still expect heavy rain and high surf, especially on Kauai and Oahu in the coming week. The contrast between 91L and Kiko underscores a vital lesson. Uncertainty is always part of meteorology. Despite advanced satellites, supercomputers, and now artificial intelligence, nature continues to guard its secrets. Forecast centers therefore remain cautious, adjusting probabilities rather than making dramatic swings, in order to maintain credibility and accuracy. For the public, the most important takeaway is that we are at the peak of hurricane season. Even if 91L fizzles out, another system could emerge quickly behind it. Awareness, daily monitoring, and preparedness remain the keys to safety for communities in the Caribbean, Latin America, and along the U.S. East Coast. U.S. Weather Outlook, September 6th. Beyond the tropics, weather across the United States on Saturday, September 6th also brings significant developments. A strong push of cold air from Canada is sweeping southward, clashing with Gulf moisture and sparking thunderstorms in several regions. While elsewhere early autumn chill is setting in. Northeast, New York, Pennsylvania, New Jersey, New England, mostly cloudy with scattered showers and thunderstorms. New York City and Philadelphia may see morning showers, with stronger evening storms bringing gusty winds and lightning risk. Highs 75 to 81 degrees Fahrenheit, 24 to 27 degrees Celsius. Dropping to 63 to 66 degrees Fahrenheit, 17 to 19 degrees Celsius, at night. Northern areas of Maine and Vermont may dip to 59 degrees Fahrenheit, 15 to 16 degrees Celsius, at night. Clear signs of fall arriving. Midwest, Great Lakes, Michigan, Wisconsin, Ohio, Illinois, cloudy with afternoon thunderstorms. Chicago's highs just 68 to 72 degrees Fahrenheit, 20 to 22 degrees Celsius, with brisk winds off Lake Michigan. Adding to the chill, Minneapolis, Minnesota could see morning lows near 54 degrees Fahrenheit, 12 degrees Celsius, an unusually early cold snap. Southern Plains and South Central, Texas, Gulf moisture meeting northern cool air triggers storms, especially around Dallas and Houston, with potential hail and gusty winds. Daytime highs 88 to 91 degrees Fahrenheit, 31 to 33 degrees Celsius. Dropping quickly to 73 to 77 degrees Fahrenheit, 23 to 25 degrees Celsius, at night. Austin and San Antonio may see lighter showers. Southeast, Florida, Georgia, South Carolina, unstable conditions. Florida faces widespread rain and thunderstorms, particularly in Miami, Orlando, and Tampa. Highs 88 to 90 degrees Fahrenheit, 31 to 32 degrees Celsius, with stifling humidity. Georgia and South Carolina also see scattered showers and storms, especially along the coast. Rockies and Intermountain West, Colorado, Utah, Wyoming, generally dry. Denver may start with light morning fog but clear into sunny skies. Highs near 82 degrees Fahrenheit, 28 degrees Celsius. Mountain towns like Aspen may see chilly 46 to 50 degrees Fahrenheit, 8 to 10 degrees Celsius, mornings. West Coast, California, under high pressure. Los Angeles and San Diego sunny and warm. Highs 86 to 90 degrees Fahrenheit, 30 to 32 degrees Celsius. Sacramento and Fresno hotter at 95 degrees Fahrenheit, 35 degrees Celsius. San Francisco cooler at 72 to 75 degrees Fahrenheit, 22 to 24 degrees Celsius. With morning fog quickly clearing. Pacific Northwest, Oregon, Washington, cloudy with light rain in Seattle and Portland. Typical for late summer. Highs 64 to 68 degrees Fahrenheit, 18 to 20 degrees Celsius. Lows 54 to 55 degrees Fahrenheit, 12 to 13 degrees Celsius. Alaska. Scattered showers with chilly temperatures. Ranging 41 to 50 degrees Fahrenheit, 5 to 10 degrees Celsius. Hawaii. Monitoring indirect impacts from Hurricane Kiko. Expect occasional showers, especially on Big Island and Maui, with ocean swells reaching 6 to 10 feet, 2 to 3 meters. In summary, the Atlantic remains dominated by uncertainty with Invest 91L, while the Pacific's Hurricane Kiko offers a clearer trajectory. Across the United States, September 6th delivers a patchwork of weather, from unusually early chills in the north to tropical downpours in the south and sunshine in the west. As always, preparedness and vigilance remain the public's best tools in navigating this complex climate picture.